3D survey and to export data from 3D survey to Civil 3D. So we'll be looking at how we can export point cloud data, how we can export digital terrain models, digital orthophotos, and additional data like contours, line works, vertical cross sections, and these sort of things. So, okay, let's go straight into it. So I have here already opened the point cloud with some DXF lines, some point cloud is in here, digital terrain model, and also an orthophoto. So now we will look at how we can export all of this data into AutoCAD software. So we will begin with point cloud. So in this point cloud, I have some 34 million points. Now to make this work a little bit faster, I will only select a portion of this point cloud. Maybe this sort of area. I will use now delete other tool to select. So now we lowered the number of 3D points to 3 million. So in order to export this into AutoCAD, we need to save the point cloud as LAS data format. So this is laser file. So LAS data format, so that's the same format that is used by laser scanning software. Okay, so we are saving this point cloud in LAS data format. We will keep the point cloud color, and this is the only option we can select. Let's press save. So this point cloud is now being saved, so this should probably take now maybe a minute or so to finish. So while this is finishing, I will just say why we only took a subsample of this point cloud. So we do this so that the calculation, so the export and import will be done faster. So okay, here is our file. Now let's see how we can get this into AutoCAD. So I have already opened here AutoCAD Civil 3D software. So here in Civil 3D, in order to import point cloud, we have to create a new point cloud here in Toolspace. So we go to Toolspace under point clouds, we click create, right click on the point clouds, select create point cloud. Now here it's important to set the point cloud style to true color. So sometimes maybe when you open this, you won't be able to click on this one. If that happens, just try to restart the Civil 3D and then it should work. Okay, here we can select the name of the point cloud. For me, this will be fine. Now let's go next to the source data. So now here we have this plus button, which will enable us to add the LAS file. So I will just go here. So let me just check where I have this LAS. Okay. Select the LAS from that location. It's this one here actually. Double click it. Okay. Next, so here we get another summary of the options. So we will have default name, true color style, and it will create a new database. In user C, okay, let's maybe change that one. So yeah, here we can also select where we want the AutoCAD to create its database file. So that's the ISD. So let's change this one from the documents. So we don't want it really there. Let's put it somewhere on our work folder. Here I have here already AutoCAD exports folder. In here, point cloud example 2, for example, open. So now the database file will be created there. Next and finish. Okay, so now this database is being created. So Here's also why I opted to use only 10% of the points. So we're only using 3 million points out of 34 million. So we're doing this in order to save some time, because this AutoCAD import will now probably take some 2 to 3 minutes, something like that. That's because what the Civil 3D is doing now, so it's changing the format of the data into its own proprietary data format. So in order to do that, it takes a little bit of time. So here we have nothing else to do but wait. Let's check what's going on with the memory. So yeah, it's running and it is ready to be attached. So when the processing is finished, we get this point cloud created. Let's click to zoom to it. And here is already our small point cloud in Civil 3D. So this one, so it says here we have the point cloud density set to 100. But if we look real closely and zoom in, so I don't think this is showing 100%. Well, maybe it is, maybe it isn't. So then when we rotate this point cloud, probably slightly less points will be shown. So this is now the, yeah, every time you move it, it will show a little less points. So maybe this one is not the most suitable to draw on, but even here we should be able to, if you just pan and zoom, now we can go to drawing lines. So even here, if we set up our point snapping correctly, so let me just do that real quickly. So object snap to node. We want also snapping to node. Let's now go to create line. So what we can do now is we can snap on the point cloud points and we can draw 3D lines just like this on the point cloud. Okay, a quick line drawn here. So you will notice so this point cloud has some 3 million points. So this one we can actually use. So, but if we had a little bit more, so this one with 3 million points, when we rotate it, it still sort of works. Now, but you can see that it's probably not displaying all of the points. So if we check this exactly, let's see how this looks in 3D survey. Let's just redo to get only this part. So here I would reckon that it is displaying slightly more points and the rotation and navigation is running a little bit more smoothly. So this is probably because we use some different logic in the back. So okay. So while we selected only this small subset of the point cloud, so I have pre-calculated another bigger part of point cloud. Let me so the whole point cloud, I will just attach it now using the point cloud attach command. Point cloud attach. So I have pre-prepared this point cloud database for Civil 3D, and it will be here in my folder AutoCAD exports. Okay, it's not really here. Actually, I know what we need to do. We need to create here new point cloud. We'll just use the same. And next, new database. Why can't I create point cloud from database? Okay, it doesn't really matter. Okay, here we change to point cloud database. No, we cannot. Okay, doesn't really matter. Point cloud manager maybe. This doesn't seem to work. Okay, let's close that one, and AutoCAD cannot continue. No, don't need to save that one. So let's just open Civil 3D one more time. So we checked how we can import the point cloud. If you import a larger point cloud, probably the 3D navigation will become pretty hard. So I think this is suitable for maybe 5 million point clouds of no more than 5 million points. Now let's get to the second part of the presentation. Let's have a look at how we can import the digital terrain model into AutoCAD. So here we also have our digital terrain model. We can display height map and show triangles. So this one is pretty dense actually. It has a 0.5 meter grid cell size, but basically the same thing works for any kind of digital terrain model. So when we are saving digital terrain model, we have a number of options, a number of different formats available. So for AutoCAD import, probably our first choice would be a DXF file. So this will probably work for smaller areas, but for area of this size with some million triangles or something like that. So in this case, if we try to load this kind of DXF in AutoCAD, it will probably crash it. So we won't even try to do this one. So we have actually two options. The first one would be using the length XML file. So this one is the easy option. I already have here a DTM XML file. I will just overwrite this one, or maybe I will just write here DTM2 and press save. So this is the easy method, but it takes it takes less user input, but it takes slightly longer. Why? You will say that soon. So to import this data now into AutoCAD Civil 3D, we just use the land XML in command. So it's already coming up. Enter. So I have here my two DTM files in my AutoCAD exports. Let's double click this one. So what we want to import is this surface. That's what's inside. Let's press OK. And now we wait. So this will now probably take a couple of minutes again for it to load. So that's because it takes a little bit more time to read the data in XML data format. So that's the downside of this land XML. It makes everything very easy because we can save this surface into one file and then use one command to load it in. And I think by now you're already hearing my computer. Also the fans are starting to get a little bit faster because now the AutoCAD is reading the file. So and we can see that the computation is running on one computer core and that it's reading the file with the speed of 1.3 megabytes per second. So with the file size of 50 megabytes, that should probably complete in about a minute. So by now the file has been read, so it's also adding the triangle information. So now in a second we should get our 3D surface here in AutoCAD. Okay, just a little bit more and we'll be able to see it also here. I guess I was over optimistic, but in any case, we should get the result any minute now. Okay, here it is. So this is now our surface here in AutoCAD Civil 3D. So here under surface properties, we can change what we want to display. Maybe we would want to turn on the points and triangles. So if we turn on the points, the first thing we should probably do is also change the point size. So let's go here, points. So now each point is 3 meters big. Let's change that to maybe 3 centimeters. Like, okay. Where did I make it too small? Or they are just below the triangles. So to make them visible, we should turn off the triangles like this. Now we can see the points. So if we rotate this 3D surface, so then the view will also change. Before we had it set to the so that only the points were displaying. When we go into one of the non-top-down views, we are displaying also we are now displaying the triangles. If we move back to top-down view, it will display the points. So this was one way of how we can get the surface into the Civil 3D software. So now let's have a look at the second way how we can do it. So now let's just delete this surface. Select it, delete, and it's also gone here from the surface tab. And the second way how to do it is by defining a new surface here and exporting from 3D Survey a TXT file with some 3D points. So here we will go to DSM, save as, here in AutoCAD, and we will use again DTM2 file name, but this time we will just use a TXT data format. So it will be DTM2.txt file. Save. So we want space for separator. 3 decimal places will be enough. Save. This is how we get a TXT file. So inside this TXT are basically just X, Y, Z coordinates. Okay, nothing special. Now let's just go to Civil 3D. Here we will right click on the surfaces in tool space, create surface. We can change the surface name by surface 1 and like that. Description, style, okay, so this isn't important for us right now. Now we expand the my surface 1, so the surface with the name we have just created. Under the definition, we have here point files, right click on point files and select add. Now let's go to our DTM2.txt file, double click on that one. Now here just be careful, so if you are importing a surface from a 3D survey, probably will be using easting, northing, Z. So X, Y, C or easting, northing elevation. This is all fine, press OK. So it's now adding the points to the surface, and we already have the surface here imported into Civil 3D. So you will notice that this import was considerably faster than using the length XML in command. So maybe that's why this one is a little bit better, because it runs a lot faster. So, okay, now we have got the surface here in 3D survey. Maybe what we can do now, maybe let's try to edit it a little bit first. Let's go to view, let's go to top, so that we have point displayed. Now, maybe edit surface, let's delete some 3D points. So for this example, I will just select the points. It's click by click. So select surface points. Maybe let's write WP so that we can draw an area where we want to remove some points. Enter. Let's remove some more. WP. Maybe let's make it across like this. Enter. 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 Okay. Now it's selecting the points. So I'm just doing this point surface edit so that I can show you how to remove the point cloud definition from this surface. So by removing these 3D points, we will make we will remove the definition of this part of the surface, so there it will be just interpolated. So there it will be just some delimited triangulation of the neighboring points. So now the AutoCAD is going into overdrive because we have selected maybe too much of the points. So now it's calculating which points are inside of this circle. Let's hope this doesn't crash. Okay, what's going on? Something is going on. Okay. Let's maybe give it a minute or two. So yeah, this is again. So this can be done, but again, it's maybe so-so. So sometimes this will work perfectly. Other times, maybe you will do something and then you will be hoping that the software doesn't crash on you while you're editing some big 3D surface. So my recommendation would be use Ctrl S to save your work a lot when doing these sort of things. Okay, I guess what we will do now, maybe let's do it. So let's repeat it. Let's close this window real quickly. I think it froze on me. So I will repeat the point cloud import real quickly, and then I will show you again how to. So let's just see 3D, open it up one more time. Okay, right click on surfaces, create surface, this is all fine, definition, point files, add, it's already here, DTM2, this will merge in Z, E and Z, okay. Zoom, right keyboard, just change that one, extends. Here is my surface, change surface style, let's show some points, increase the point size, apply, okay. Now, so we want to change the surface here a little bit and then import it back into 3D Survey. So let's see how we can do that. So we'll go here to surface, edit surface, and let's delete some points. So we'll use the VP command. I think this is window polygon or something. It stands for something like this. Enter. So now the software is again selecting the points inside of this polygon. Hopefully this time we'll have more luck. Points are selected. Okay, enter, and points are deleted. Great. Don't want to do that anymore. Let's rotate the surface a little bit to see what we have done. So you will see that what we have now, so maybe not the best interpolation, so what the software does now, it makes the linear triangulation of the border points of the surface, and it fills it up like this. So yeah, maybe useful, maybe not. Let's just go to top-down view again, and let's also add some of our own edits. View top-down. So now I will just add a couple of break lines, and I will just do them maybe like this. Okay, enter. One more like this. Snap, why it's not snapping? Center, not, maybe not. Yeah. Snap to not. Another line. Another one. And one more down here. And now we will add these lines to the surface definition. So this can be our manipulation of the surface now. Let's select these lines, right click to confirm. Okay, we can now even delete those lines. So to delete them, we need to do it like this. Okay, now let's turn the surface a little bit. Okay. Okay. Now let us, so I guess the break lines it didn't work 100%, but it goes in this sort of way. I think the deletion was too much. Now let's export this surface into a 3D survey. To export it, we have to use this one, export to digital elevation model. Grid spacing, I will set it to 0.5 meter in my case. You can use also the feet. So then, really important, you have to set the DEM file name. And when you are setting DEM file name, you have to set it to this one, GeoTIF. So GeoTIF surface, we will name it surface to TIF. Save. Okay, so now it's exporting the surface, so it's sampling the elevation of this surface. And once we have this TIFF file, we can now go to to a 3D survey. Let's hide this one for now. Let's go to DSM, load, GeoTIFF. It's in here, surface to TIFF. Oh, and here is our surface back. So this was the original surface. This is surface 2. They're pretty undistinguishable except for the area here where we see these triangles. So this is different. So we removed some detail from the surface here. And this is how we can use, how we can switch this surface data from Civil 3D to 3D survey and back and forth. So maybe a civil engineer will create a surface in Civil 3D, he will give it to a land surveyor, and then we can import it in here, export it from here to there, and vice versa. So that's pretty useful. Okay, so we have covered point cloud and digital terrain model. Now let's go also to orthophoto. So again, orthophoto, to save it, to export it to Civil 3D. So when we are saving orthophoto, when we go to orthophoto, save as, AutoCAD exports, I'll just delete these two for now. Maybe create a new folder in here so that we will be all working from a fresh folder. So for the first file, I will save it as ortho underscore word file JPEG. I will use JPEG, but this works also for TIFF or PNG. Press save. Now, when we do this, the software now asks us how we would like to georeference our data. So by default, we will use this Word file. So what is a Word file? We will see this in a minute. So now the ortho Word file .jpeg was created, and a JGW file. So as a non-English speaker, this one is a little hard for me to say, JGW. So the contents of this file is just the georeferencing information, so it just has the pixel size. So these two numbers, they give you the rotation. This is actually size in easting. These two values are for rotation and for skew, and size in northing. So this one is always negative. And then we have the coordinates of upper left corner. Okay. Now, if we have Civil 3D or AutoCAD map, we can load this kind of ortho into Civil 3D or AutoCAD map by using map I insert command. So map I insert. So once you go to map IIN, it will automatically make these suggestions. This one here in new folder, I have this file. So here we now just select the ortho Word JPEG and the JGW file, so that's the Word file. That one will be ready automatically, and here we will get the insertion point, and from the pixel size it calculates density, so that's basically how many pixels per meter per unit. So it will be pixels per feet or something like that in American part of the world. So now let's just press apply. OK. So now our image is pasted into the AutoCAD, so it's correctly positioned. It's only at the 0 altitude. So if you want to see it, where it is over the digital terrain model, we just go to view, to top. So now our surface is covering the orthomap. So now I have selected the surface to make it, I have selected the orthomap to put it on under the surface. Let's just use this one, send to back. So now we are displaying the points. I'll just quickly change this one. It's of the style and display. I just want contours and points. Right, okay. Great, better. So this one, so if we are making a 2D map, I think this is the best way to do it. Once you have ortho inside, we can make really quick drawings. One thing you will notice, so when I'm drawing, you see that the CV3D, so it makes the picture a little bit blurry. So when you will see this effect that comes up around the line, so every time we make a line, you can actually now see the pixels. So if it were up to me, I would be displaying image like this with pixels, not blurry, but it's workable in any case. Okay, we don't need this one. So this was the first way of how to georeference the data. So now we also have a way for the people who, okay, I accidentally deleted the line. What I wanted to remove was the 3D surface, the ortho map. So let's see now, display order send to back. Now let's select the image, delete. Yes, I also want to attach the image. Now the second way of how we can georeference ortho map is to use the DXF frame. So this one is for the people who use the regular AutoCAD. So I will save a new JPEG file named ortho DXF frame. Save. And here now we select DXF frame. Save one more time. So for this one now, AutoCAD, I mean 3D Survey, will create image and DXF frame for that image. So to get this in any kind of civil of AutoCAD server, so AutoCAD software, we just now use insert command, and here we will select the DXF frame. So for this one, we want insertion point at 0, 0, scale should be 1 and 0 rotation, and unitless works best for me as a unit. Okay. So what we got now is we got this frame. So this is my current layer, this is the DXF frame. Now what we can do is we can insert the image into this frame using the attach command. Attach, enter. Here I will select ortho DXF frame.jpg. Okay, so you should specify scale and rotation, in this case on screen. So now you just select the lower left corner of the frame we have just inserted, so this one should be done pretty accurately, like this. Zoom out. Now let's set the scale so that it makes sense. Let's something less, maybe like this, like so. Okay, and now we just make it fit to the frame. Just scale it like this. And again, draw order, send to back. And okay, you see that it fits perfectly. We can see the road contours, which are flat. So, and this is how we can get the orthomap into AutoCAD software, so even if we don't have AutoCAD map or Civil 3D. So, okay, this is great. So, we are now done with the most interesting part, so exporting orthophoto digital terrain model and point cloud. So here you see that we also have some DXF lines. So if we want to, so this we can draw here in 3D survey. Then to get them into AutoCAD, the process is very straightforward. We go to data, save CAD as. I will put it in here into this new folder, finish line works 2.dxf, save. File is created here, and now in AutoCAD we will just use the insert command again. So similar as for the frame. Okay, and it's exploded. I guess it didn't explode it, so we now have also our line work here in AutoCAD. So these are the lines that were drawn, for example, in 3D survey. Okay, so let's move to 3D survey. What else we can export? So we can also create a vertical cross section, calculate profile, just the simple one will do for this thing. And let's do a cross section like so. Right click to confirm. Okay, I have a cross section like this. Maybe let me make it a nicer one. So this works best on a classified point cloud, so that in the point cloud we don't have buildings or vegetation. Let's make a cross section here, down here, where we have nice ground. Maybe like so. Okay, nothing special, but it is a vertical cross section with the road here. Now let's export it into DXF. Let me just move to our exports folder. Profile, we will name it file. Okay, and in Civil 3D, we will again use insert command. Browse profile to get the cross section. Okay. So what this does is it creates a vertical cross section like this. It also makes these points, so these we can actually hide. So let's just explode this one. So it also exported a lot of points, so now they are below the surface. I just need to put the surface draw order to back one more time. Maybe we should just hide it for now, so it's not showing up. So what happens is, here you get the points the cross section was calculated from, and you also get the cross section in 3D. And so here it is. Maybe a little hard to see, but okay, this is our cross section in 3D. But if we move to a different part, so let's go to View, Top. And here at 0, 0 position, you also get the cross section. You just maybe have to set the color of the, to make it a little bit better, maybe like that in red. So, and we can change slightly the size of the text. So, style text, height. Let's try half a unit. Maybe this will work. So, okay. So, and this is at 0, 0 position. You get this kind of and this will just do it. You get this kind of vertical cross section. So if you would have more, you would have them here, one above the other. So same way goes for the contours. So we have now covered most of the data exports. Let me just go back. So I'll just delete these vertical cross sections for now. Use zoom extends. And okay, let's leave this surface inside. Now I will also export the contours from 3D survey. First we have to calculate them. Calculate contour lines, 1 meter equidistance will be fine. We have contours, export DXF, so we can select whether we want 2D or 3D DXF. So if we select 2D, they will all have the altitude of 2 meters, but they will just be used to display the contour shape. And then in 3D, so in this case the contours will be full 3D, so it will be at its own height. So for this demonstration we will use 2D DXF. Let's place this into our AutoCAD export folder and use the contours name, contours DXF, save. Okay. Now here again, using insert command, go to contours. Okay. And okay, so we have also now imported the contours. What you will notice is that these contours in 3D Survey, they are pretty much the same as the one generated by AutoCAD. So we have slight deviation, so ours is a little bit more smooth, but more or less they are pretty much the same. So except for this part here where we have deleted some points from the surface. So that's why here the AutoCAD contours are slightly different. But other than that, mostly they are pretty much the same. Okay, maybe in the case of AutoCAD here you see they can get a little bit jaggedy. Oh, but okay. So this was it. So we had a quick overview of how we can export the data from 3D Survey into AutoCAD. I would like to thank you very much for listening to this webinar, and see you later when we will be doing these webinars, one new advanced each week. So the next one now I think will be on how to measure a railroad or a railway. So looking forward to seeing you on the next Thursdays. For today this will be it. Thank you very much and bye bye.